Welcome back to the video lecture series for Introduction to GIS. Today what we're going to be talking about is we're going to look at several different ways to create data that basically comes from a table. So the first thing we're going to talk about today is geocoding. We're going to talk about what the geocoding process is, and then look at some examples of geocoding, and then later on we'll actually do some geocoding operations. We're going to compare the geocoding process to plotting data using XY coordinates, and then lastly we'll look at one other way to quickly create features. Today's video will primarily deal with quick ways to create data from tables, and then tomorrow we will look at the actual editing process and how to create data in a way that's much more similar to the drafting process. Okay, so here we can see this is an example of point data that has been geocoded, and what this is really displaying is crime data in Radford City over a one-year period. And so we're going to talk about how we can take, for example, information about crimes that's been recorded with an address and give that a place on a map. Okay, so to start off, let's talk about what geocoding is. I want you to think of geocoding as the process of transforming a description of a location. So for an example, we could have a pair of coordinates, an address, such as 115 Main Street, or maybe a name, for example, Radford City, or it could even be a description that refers to a place on the surface of the earth. So we could maybe take something like a point of interest or a name, so maybe like a mountain range, we have Paris Mountain, and if we had the right sort of geocoder, we could plot or identify that location on the map. So again, geocoding is a process of transforming a description of a location into a point on a map. Geocoding can be used for a lot of different purposes. Most commonly it's used when dealing with address data. So it could be used for some sort of simple data analysis where a business is wanting to do some sort of customer management or look at different potential distribution routes for, based on where customer locations are. You can also, plot different types of coordinate-based information and look at different types of patterns that are within the data. So geocoding is all about plotting point data. And like I said, most commonly this deals with addresses, but we can kind of think outside the box. So we know an address for a house, we know what that looks like, but there are many different types of electronic addresses these days as well. So think about maybe an IP for your computer, or could maybe even be a cell phone, or in a university maybe we could geocode classroom data. So we might want to know how many students are in a classroom at any certain time of day, and if we had information from maybe the university that told us tabularly what the classroom name was and how many students were in there at a certain time, we could effectively plot that information on a map using different types of geocoding operations. To go through a couple examples here, we'll look at probably the most common example, which is crime data. So imagine that we had some annual records of burglaries that were initially stored in a database, but by using geocoding, we were able to convert that address into a physical point on the map. And then once we have that point on the map, we can symbolize things based on maybe the time of day that the burglary happened, or the season, or well, it could actually be anything, any other type of data that we have in the table we could use to symbolize the information, and then we could look at different types of patterns. So for down in this map, for example, we have burglaries, and the ones in yellow are the ones that happened at nighttime, and the ones that are in blue happened in the daytime. So you can begin to make some comparisons about where burglaries happen based on the time of day. So again, a very useful way of converting tabular information into point-based spatial information. Another very common application of geocoding is in customer data management. So I want you to think about most businesses. Nearly every organization or business company that's out there has some sort of organizational information that relates to customers or clients. And almost all of those customers or clients have some sort of address where they're maybe billed or where goods are dropped off or delivered to. And what these companies do is they take the data that's in that tabular format, they use geocoding operation to plot it on the map, and then they can spatially look at things like buying habits. I know back last Christmas at an outlet mall in Leesburg, Virginia, they were tracking people's buying habits. So they would use cell phones and they would pinpoint locations and they would say, hey, I know that these people walked into Eddie Bauer, and then after they went into Eddie Bauer, they maybe walked down the road and went into another business. So they can begin to look at these spatial buying patterns, purchasing patterns, or other things if we have this sort of point level information. So again, geocoding allows you to take this tabular data that has either an address or some other description of a person's location and put that on the map as a point. So there's other uses maybe that for geocoding that include developing marketing strategies to target maybe specific clusters of people. It's also used extensively in route mapping and in direction giving. So many of you are probably familiar with Google Maps, where you type in your address, it plots it on a map, and then you say I want to get directions to another place. You type in the address of the location you want to go to, and voila, you have 2 points on a map in these detailed point-by-point or turn-by-turn driving directions. So whether or not you realize it, geocoding is a piece of technology that's used very often in many sorts of your mobile phone applications or other technologies that you use on a daily basis. Another area where geocoding is used quite frequently is in a program or an extension in ArcGIS called ArcLogistics. And this is a specific type of application that uses geocoded addresses to optimally plan how a company would deliver goods to a customer. So there are companies like UPS or FedEx or maybe even some sort of pizza delivery company in your area that use programs very similar to ArcLogistics that use geocoding data to optimally plan routes. This goes along very closely with something called distributed geocoding applications. So think of these as online websites, tools, or apps that allow users to geocode addresses over the internet, and many times these distributed geocoding applications work hand in hand with direction producing applications. So think of MapQuest and Google Maps or Yahoo Maps, Bing Maps. All of these things basically use some sort of geocoding operation that's executed over the internet. One thing I want you to think about when as we start to develop geocoding or do geocoding operations is that it's very important to have good reference data. So for example, there would be no way for you to find out where 380 New York Street was in Redlands, California, if you only had map data that was referenced in Canada. So you need to really think about the level of detail that you want in your geocoding operation. So one, you have to have data for the appropriate region, but two, you have to make sure that it has the appropriate level of detail. So if you have a map that only shows highways in major cities, it would be very difficult to geocode an address for somebody who might live in a suburb because you didn't have the appropriate level of detail, and you could really maybe only geocode that location to the city level or to the highway level. So the more detail you have in the data, the more you'll be able to pinpoint that location, and it's something that you really do need to think about. So do you want to geocode data to the county level? Do you want to do it to the zip code level, to the state level, or do you really want to go down to that street level, which is what many types of geocoding operations are done at, or for example the crime example that we looked at earlier. So think about the data before you go about doing anything that involves geocoding. Okay, so you've probably already watched the other videos that we had posted from Esri that kind of went through some of the basics of geocoding. And so I want you to really think about this thing called the address locator. This is the major component in the geocoding process, and it's created in a certain style. So there are many different styles of address locators, and what these styles do is they basically dictate this set of address parsing rule and matching rules and how the geocoding process is performed. So some styles might be what we call a dual range address locator, where we have even and odd addresses on the left and the right side of the road, whereas other geocoders might only use zip code. So remember that we call the engine that does the geocoding the address locator, and there are many different styles of address locators, and you pick that based on the the needs of your analysis. So I want you to think of this thing called the address locator as a street guide or a map book that you use to look up an address, or also maybe a description about a particular place on the surface of the earth. So what this address locator does is it maybe directs you to a page that you have in this map book, and it pinpoints that location based on the address that you've described it. So it's kind of the digital version of a map book. So what this geocoding process or the geocoding engine does, which all links back to the address locator, is it converts an input address into pieces. So for example, there's a number, a street name, and a street type. And all of this information is used in the address locator to identify this point location. So we refer to all these different pieces that fill in the information the address locator needs as address elements, and depending upon the type of address locator that you use, sometimes you can get multiple interpretations of the same address. So maybe one address locator plots an address location directly on a road, whereas a different type of address locator offsets that point location and puts it slightly to the right or to the left based on a fixed distance. And anytime the address locator generates an interpretation of an address, it will also give you a score that basically indicates how well the computer thinks that address was matched. And you can actually set different sorts of score tolerances. So you can basically say, hey computer, plot that point if the score is at least an 85, and if it's 85 or below, I want to manually interpret that point myself. So there are a lot of different options and flexibilities within the geocoding process. Here's an example of what we might call a dual road range geocoder. So a dual range geocoder has ranges on both sides of the road, and we know that those are kind of split up between even and odd addresses. So there's a left house number range and a right house number range. There might also be a prefix, so North Main Street or West Redlands Boulevard. There's also maybe prefix types. Then there's the actual street name, the street type. There's also suffixes. So just like there's a prefix, there might be a suffix. And then we also have the city name, the state, and the zip code. So the entire kind of address component is broken up into different fields, is what these all represent. So as I mentioned, this is the dual road range, but there are many others. So here we have the dual range one that's based off of a line, a road line type. There could also be a single type road range, so we don't really care about even and odd sides of roads. There are also single house or point-based locators. So if you have some sort of reference information that might actually be a building, and we have the address of that building, you can plot points within those buildings instead of along lines. There are 5-digit zip codes, a little bit more detailed zip code plus the additional 4 digits. There are very general ones that deal off of city, state, or county, or even country polygons. And then, as I mentioned before, there's kind of the gazetteer data that refers to geographic place names. And then you can also build very custom ones that maybe deal with non-traditional data and use single fields. So for example, we talked about how there could be a classroom geocoder that you custom design based on the specific data that you're working with. So you might pick this general single field locator. But there's a whole lot of different types. That's what I want you to think about. And so we pick the type of geocoding operation based on the data that we have. To get into a little bit more detail, let's graphically look at what the dual road range geocoder is doing. So here we have a road segment, and we have even addresses on this side of the road, and we have odd addresses on the other side of the road. And so this segment right here is 5th Street Northeast. And imagine that we have an address that is 160 5th Street Northeast. What the geocoder is going to do is it's going to first identify where 5th Street Northeast is, and then it's going to search these values for the left from address, which is here, and then this is the left to address, which is here. It's going to say, hey, my number falls somewhere between 134 and 178, and so it's going to compute the length of this line and then the difference between these two, and it's going to interpolate where it thinks that number is. And so 160 is somewhere maybe in between these two, so it might identify the location as being right here where my mouse cursor is. So it would put a point on the map right in that location. Now, if it was 161, it would know that it would have to go to the odd side of the road, and it would plot that point over here. Now, if we were not using a dual range locator and we had a single range, so instead of 134 and 135, we just had one number from here to here, it would plot that point directly over top of that line. So the dual range is basically a more detailed type of geocoder than the single range. Okay, here's another example of a zip code geocoding operation. So instead of having roads, we have polygons, and inside the polygon is the actual zip code. So maybe in a table, we have a field that only contains zip codes, and what the geocoder does is it puts a point in the middle of that polygon. So here we can see 92405, 92405. This point is basically smack dab in the middle of that polygon. So it works a little bit different than a road range based geocoder, but it's still the same concept. We're taking information from a table and we're plotting it on a map using some sort of reference information. Okay, now geocoding gets a little more complicated because you can link many different types of address locators together. So earlier we talked about maybe the level of detail that you need in the particular type of analysis that you're doing, and so maybe you need to be at the street level, but not all of your data has perfect street level information. So maybe you need to build something called a composite locator that links together many types of address locators at different levels of detail to try and find the best possible matches. So for example, we might start off here and we might use the citywide locator and try to make a match. If we can't, because the information isn't as detailed as we need, it might drop down and use the nationwide locator. If it still can't find an address, it might go and use the postal code locator. So every time a record is matched, it gets sent out, plotted on a map. If it's not matched, it drops down to the next type of locator, and so on. So this is a very kind of neat thing to use if you have data that comes from many different places and is stored in different formats, and you're having some geocoding problems. You can link more than one geocoder together to more effectively plot your data. Okay, something that's very important in geocoding is that you make sure that you standardize your addresses. So a lot of times when people just record address information, they want to write it all out in one line in a field. And while this is okay, it's not the optimal way to do it. It doesn't produce the best geocoding results. So it's much more effective to separate out or to standardize all the information so that you use kind of standard field names, and then you record each piece or each address in element in its own individual field. And if you follow kind of this default or standard template, you'll have a lot more success in geocoding, or you'll have more records that are successfully plotted on your map. Okay, so now let's move on to a different way of creating data from a table. So earlier we talked about geocoding and all the different ways that we could geocode data or information. And what geocoding does, as I mentioned before, is it takes a description, and based off of that description, it assigns an XY coordinate to a record in a table. So it plots information as a point based on the description. This other method, the DisplayXY method, actually takes XY coordinates from a table and plots them by referencing an appropriate coordinate system. So down here, we can see in the table of contents, and we go back to lab 2, we had a table called ivorylocations.txt. And if you looked in that table, you might have seen that there was some XY data. Now, I want you to think or remember that XY data is referencing a latitude or something very similar to latitude and longitude, or northings and eastings. So it's kind of just a different way to talk about coordinate pairs. So here we can see we have an X coordinate, which is basically referred to as an easting, and here we have a Y coordinate, which is also referred to as a northing. The reason the numbers look slightly different is because these fields have different levels of precision. Now, what I've done over here additionally is I've converted the northing and easting data into lat-long data, and I just want you to know or really pay attention to the fact that there are different systems for recording XY information. So we refer to northing and eastings when we're dealing with state plane coordinate systems or UTM coordinate systems. Latitude and longitude is often used when we have a geographic coordinate system, and this is very common when we're dealing with GPS data. Most people record GPS coordinates using latitude and longitude, and it's either in degrees, minutes, and seconds, or it's in decimal degrees. But it doesn't really matter as long as you have a field that contains that X and the Y data. You can go in using ArcGIS and you can right-click on that particular table, go to Display XY Data, and then match the X and the Y field so it knows what to correctly reference. And then this is really, really important that you have to pick the correct coordinate system. So here I have X and Y in my XY field, and I'm referencing a geographic coordinate system. So to properly display this XY information, I would have to go in and actually tell it that the X field should be lat and the Y field should be long. So you have to make sure that you correctly do that part. Let's see. Displaying XY data is a very handy or useful trick, especially if you're someone who is conducting field research or maybe just recording information in a table, and you're not used to maybe using a GIS. You can always take that information from that table and plot it on a map. So geocoding, displaying XY data, very handy tools when all of your information is stored in a table and doesn't necessarily have a spatial component. Now, to finish out this lecture, I just want to mention that there is another very quick way to create data that is different from editing feature classes. So there is the drawing toolbar, which you can access by right-clicking in the toolbar area and turning on draw, and you can use that to basically draw features on a map. Now, this is very quick, but it's not really a best practice. because the graphics are different than features. They're different in the sense that they don't actually show up in the table of contents. So you can't run tools that typically would run off of a feature because graphics are not features. So if you have been using the draw toolbar to put objects on your map and you want to somehow get those into your table of contents and turn them into a feature, give them a coordinate system, what you can do is in the drawing toolbar you can click down on the options, you can highlight the particular graphics that you're interested in, and you can convert those graphics into a feature. So this is a very quick way to get polygons or lines or points that you drew on top of a map into your table of contents. But as I mentioned, it's not really the best practice, and in the next video series I will talk about the correct way to create new features on a map. So that's all for this particular lecture. What I want you to remember really is that we talked about geocoding and displaying XY data, and both of those specifically deal with converting data from a table or spatially enabling data in a table. So we're converting tabular information into spatial map-based information. And what we're going to do now is we're going to go into D2L, and we're actually going to walk through the process of doing this a couple times for the upcoming lab. So we're going to go here to a web browser, and we're going to go to our contents, and then we're going to scroll down here and find our labs, and we have lab 4, and we also have lab 4 data. And so I want you to download both of those. So I'm going to open up my lab 4 PDF, and I'm actually going to download this so that I can view it a little bit better. Okay, and then I'm going to go back to D2L. Let's see here. Oh. And we'll get the data. And remember, this is a zipped folder, so we can't use it unless we extract all files. So immediately after you download it, I want you to hit extract all files. And I'm going to change my extraction location to my documents, just because I like to keep all my information in the same place. So I'm going to go to my documents and make a new folder called lab 4. I'll hit OK. And we'll go ahead and save that there. Okay, so now we have lab 4. Okay, and I'm actually going to save my PDF in that same lab 4 folder. Let's see here, save, documents, go to lab 4, and I'll save that in there. Okay, we're good. Alright, so this lab deals with same stuff as the previous lecture did, where we're creating point data from tables. So what we're going to do is we're going to geocode some addresses, and then we're going to mimic using a GPS by extracting XY data from Google Earth and storing that in a table. So in this lab we'll learn to convert street addresses into a GIS layer, and we'll also learn how to take data that would typically come from a GPS and turn that into a layer. And then we'll also learn how to compare. What we'll do is we'll compare the point data to the GPS data to look at which one did better. So you know, in some situations, street addresses might be fine. In other situations, GPS data could be better. But you know, who knows? We have to kind of look at the differences between the two before we can pick maybe what the best method of creating point data is. So there are two parts to the lab here. The first one is that we're going to create point data of restaurants around Radford University using street address geocoding tools. Then we're going to, using Google Earth, identify the GPS locations of those same restaurants, and then we will plot that XY data on the same map where we plotted our geocoding data. So maybe we're going to pretend here that we've collected the GPS data using our smartphone, but since we all don't maybe have smartphones, we're going to just extract this information from Google Earth, and then we're going to make a couple maps, and maybe then write maybe a half a page comparing the data. So there are a couple basic steps that we need to follow here, and what we're going to do is we're going to create our table in Microsoft Excel. I don't particularly think this is the best method, but many students find it to be easier, so they like working in Excel rather than creating tables in ArcGIS. So we'll stick with that method for now, but I do want you to know that there are ways to do the very same thing within ArcGIS. Most people are just more comfortable with Excel. So what I'm going to do here is to start the lab, I'm going to go to Microsoft Excel, and I'm going to make a new table. So I'm going to go to File, let's see, in Save As, and I'm going to call this Lab 4. Lab 4 table. Lab 4 underscore table. And I'm going to save that again in my documents, and I'm going to go find my Lab 4 folder and save it in Lab 4 data. And we can save it as .xlsx. That'll be fine. I'm going to get rid of my recovery so you don't see this. Okay. Alright, so what we need to do first is we need to create some field names. Now, if we create a table in Excel, ArcGIS is going to read the very first row and identify that as field names. So the first row is where we're going to type in our field names. The first one is going to be called name, and this will be the name of the restaurant. Now, I want you to be very careful to not have any spaces in your field names. It will cause errors, and ArcGIS won't be able to read the table. So the first one is name. The second one is going to be street underscore num for street number. The next one is going to be street, we'll call it name. And then we're going to go with city and then state. Even though we're only dealing with Radford, this is the appropriate way. Maybe we had restaurants that were in more than one cities and more than one state. We might want to have all this information. Okay, so now I need to find some addresses or some restaurants that are within Radford, and for the sake of this exercise I'm only going to do a couple. I want you guys to do a minimum of 10. So what I'm going to do is I'm going to go out here and I'm going to open maybe Google, and I'm going to type in restaurants in Radford. Okay, and we can see that a bunch of stuff pops up here. So let's see. It's already got a map of them for us. So I'm just going to click here, map for restaurants in Radford, and we can go in and we can actually click on these, and we can get the address. And so, believe it or not, what Google Maps has done is it has done geocoding over the internet, which is the same thing that we're trying to do or replicate on ArcGIS desktop. So we're learning how to create geocoders and how to we're learning how Google does this in all of their maps. So I'm going to go in here, and we see it's 709 West Main Street. So I'm going to go to my table and type in 709 for the street number, and then I'm going to type in West Main Street, Radford, VA, and that was Sal's restaurant. Okay, now we're going to go back here, and we're going to look at another one. So we'll click on McAdoo's, and we'll find the address for McAdoo's. So it's 510 East Main Street. Okay, so we'll go back to my Excel table, and we'll type in McAdoo's, and it's 510 East Main Street, again, Radford, VA. Okay, now we'll do one more, just for demonstration purposes. We'll go ahead and get, let's see, River City Grill, which is 103 3rd Avenue. And I want you to pay attention to how I type things in, because Google uses 3 as in the number 3, but I'm going to type in 3rd Avenue. And depending upon how you standardize your addresses and the different rules that you set up, things like that can be very important. So here I'm going to go back because I forgot what that was. It's 103 3rd Avenue. Okay, so then I'll type in 103 3rd Avenue. This is Radford, PA. And instead of Sal's, we have River City Grill. Okay, so now I've got information that's going to be very useful for my geocoding. But there's two parts to this lab. We also want to display XY data. So I'm going to go in here and I'm going to type in X for an X coordinate and Y for a Y coordinate, because we're going to be plotting data based on two different pieces of information. If you wanted, you could create one table for street addresses and one table for XY data, but then you would have to kind of enter this name more than once. So by putting all this information in one table, it's much more effective. Okay, so somehow we need to figure out the X and the Y coordinate for these restaurants. And if we had a GPS, we could go out in the field and collect it, but we don't, because we're taking this class online. So instead we'll use Google Earth to kind of mimic collecting data with a GPS. So I'm going to open up Google Earth. If you don't have it, it's easy to download. You can just do a Google search and download it. It's a very quick install. And okay, so it opens up here. And what we're going to do is we're going to type in Radford, VA, so that we can zoom the map in, to Radford. Alright, and we're going to go down here to layers and turn some other stuff on. Maybe we'll turn on places, and let's see, more, just kind of trying to see if we have any information that might relate to restaurants. But you know, we all have some local knowledge of this place, and you can also see that there are some legend or some items that pop up on the map relating to different places in Radford. So I want you to kind of find these address locations using Google Earth and maybe other maps to help you reference it. And so here I've found McAdoo's, and so I'm going to go in, and if you hover your cursor over the map, you can see that in the bottom right here you get an XY location for wherever your cursor is. Now mine is in decimal degrees, which is the preferred format for plotting XY data. But sometimes, especially if you just installed the software, it might be in degrees, minutes, and seconds. So you can go in your tools and options, and you can change the actual lat-long format. So you can use UTM, you can you know, degrees and decimal minutes, or degrees, minutes, seconds, or what we're going to use here is decimal degrees. So make sure that that option is checked. And so what you need to do is you need to hover over where that building is, and I'm going to use the middle of the building because I think that's the most accurate kind of way to plot that location. And then you need to record the lat and the long. So for this particular feature, our latitude for McAdoo's is 37.13672, and you want to make sure that you use all those decimal places, because when you're dealing with decimal degrees, maybe 1 degree is somewhere around 69 miles at the equator. So you know, if you kind of truncate that, your data is going to be far less accurate. So my lat, okay, I got that, and my long is going to be negative, and that's very important, negative 80.54376.9. Okay, so now that we've recorded that, we'll go back to our table and we'll find the appropriate entry, which is McAdoo's. And now I need to take my lat long and put it in as XY data. Now I want you to be very careful. You need to think about this. Is latitude or longitude the X? A lot of times people confuse this or they do it incorrectly, so I think it's really helpful to just draw out a graph and think about, what your X and your Y axis is and how that corresponds to latitude and longitude. So our X here is going to be longitude, so it'll be negative 80.5437769, and then our Y is going to be latitude. It's going to be 37.136722. And we can make these fields bigger to make sure that all of our numbers are actually there. Okay, so we got our X and our Y, and now we're going to go back to Google Earth and we're going to try to find Sal's. So I remembered that Sal's was on the other side of Radford, so I will go over here and let's see, there's Applebee's, so I'm not far enough. Let's see, Bucko's Pantry, mortgage company, so I'm going to have to go to my map and kind of reference. So we see Sal's is over near Robertson. Is it? Where's Sal's? Yeah, it's over near Robertson and West Main Street. So we'll go back to Google Earth and let's see. Don't have any road names here. Borders and labels. And roads. Turn on road labels. Okay, so there we go. Now we're getting somewhere. Henry, so we're looking for Robertson. There's Staples, Preston. Getting there. Robertson. All right. And look at there. We got El Charros. And oh, look, there's Sal's. Okay, great. So I'm going to hover my cursor right around there. And again, record the lat and the long. So we got 37.130682 and negative 80.58186.5. Okay, so now I'll go back to my Excel table, find Sal's, and we'll type in negative 80.5437769 and 37.130682. Okay, now we can look at the importance of these decimal places here because we're all in the negative 80.54 and the 37.13 range. So these numbers at the end are really what's telling us what's different. And you can even see I just made a typo right here. I used the same coordinate for McAdoo. So you got to be very careful that you don't make those mistakes. So it's negative 80.581865. Okay, so now we've got the correct X and Y for Sal's. And lastly, I'll go in and I'll do the River City Grill. So that was again over on the other side of town, and it was near downtown. And there's got River City Grill. Let's see here. Let's fix my map plane. Oh, there we go. So here's River City Grill. And I'll go into the middle of the building. hover my cursor there, and again record the lat long. So we got 37.140.519 negative 80.557973. Go back to Excel and type this in. Okay, so what you need to do for this lab is do a minimum of 10. The more you do, the better, but for the sake of time, I'm only going to do 3. So here we have field name and our first 3 entries. So we'll go up, we'll hit save, and it's very important before you go to ArcMap that you close down Excel. So you never want to have both programs or both tables open at the same time. Things get confused, they don't work right, everything goes crazy. Okay, so what we want to do here is we want to find some sort of base map so that we can use, have some background streets and roads and other things to overlay our information on. And the base map that I like is the National Geographic one. So you'll go to ArcGIS Online in ArcMap, and I want you to go to File, right here, File, let me show you, File, ArcGIS Online. Okay, so after you've added your National Geographic base map, I want you to zoom in to Radford, or you can also use the binoculars to find a particular location or area of interest. I've done this a lot of times, so I can zoom in pretty easily. So we've gone ahead and focused our area of interest into Radford. And the next thing that we're going to do is go to our catalog, and we're going to find our data that's in our Lab 4 folder. Now, sometimes when you create new files and ArcMap's already open, those files don't show up in catalog, so it's always a good idea to go ahead and right-click on your base folder and go to refresh to make sure any new files pop up in the catalog window. So we'll go down to Lab 4, go to Lab 4 Data, and here you can see the Excel spreadsheet that we created. Now, you can't add an Excel spreadsheet to ArcMap as a whole package. It'll give you an error and it fails. And this is because Excel stores data in multiple sheets. So here we can see that our Lab 4 XLSX has sheet 1, 2, and 3. And in this particular case, the first sheet where we entered our data was sheet 1, so we'll click on that and we'll add that to ArcMap. Now, anytime you're creating data in Excel and then you add it to ArcMap, it's really important that you go and explore the data to make sure that it's come over correctly. Now, in this case, I can immediately see that we have some sort of error in our city field. So something went wrong here. It's not working correctly. Radford's gone. So what we need to do is close this down and remove the table from ArcMap and then reopen Excel to see if we can isolate or figure out what the error was. So we'll go here in File and we'll open the Lab 4 table. Now, I mentioned earlier that you've got to be really careful about opening a file in Excel, closing it, and then opening it in ArcMap and closing it, and not having them both open at the same time. And even when you are careful, you still run into issues like this where it's telling me that the table's locked for editing. So for some reason, ArcGIS still has a lock or permission lock on this file. So I'll just open a read-only copy and then save it as something new. So we go in here and we know that city was the field that was messed up. So I'll start immediately by clicking on the city field name and then clicking up here in the entry window, and I can see that my cursor is a space to the right of the Y. And what this means is that when I typed in city, I hit spacebar afterwards, and this basically means there's a space in the field name. And as we know, spaces are illegal characters. So we'll go ahead and we'll delete that space, and we can go back and we can confirm that it's gone by re-clicking here. We say, okay, city name's good now, no spaces. We'll go in and we'll resave this file. This time I will call it Lab 4 Table 1. So I kind of keep track of the different files I create. So go ahead and hit save. Then I'll go ahead and close all this down. And then I'll go back to ArcGIS. and re-add that file. Again, we don't see it in our Lab 4 folder because we need to refresh it. Maybe we have to actually go all the way up to Documents and refresh that. So we'll refresh Documents, scroll down to Lab 4 data, and there's Lab 4 Table 1. I'll go ahead and I'll add this to ArcMap, and then again open it to make sure that it worked. And in this case, all the data came over correctly, so now we're good. Now, the first step in this lab activity is to geocode these addresses, and there's been some changes within the geocoding kind of world with ArcGIS 10.1 and 10.2. And there used to be a lot of, if we go here, we right-click on our sheet and go to Geocode Addresses, there used to be a lot of free geocoding services, but now many of these are blocked or restricted unless you pay for access to them. And so what I've done for this lab is I've created a Radford Geocoder, which is in your Lab 4 folder. So if you hit the Add button, you can go in there and you can add the geocoder that I created for you, similar to what you did in the geocoding lesson with the Atlanta reference data. So basically what I did is I had some road data for Radford City, and I went through that same geocoding process and created this Radford geocoder. So we'll go ahead and we'll hit Add so that it adds to the list, and we'll go ahead and hit OK to use that one. Now, before I mentioned there were many different styles of geocoder, and the particular geocoder that I produced here is a dual range one, but it only wants the address as one line. So it's a little confused here. It's trying to match kind of fields, and it's saying, hey, look, what should the address be? Should it be name or street num or street name? It doesn't really know because it can't find an appropriate one. And if we go look at our table, maybe we didn't set it up in the perfect way. We did follow kind of the standardization process where items are parsed out, but like I said, this style of locator wants them to be together. Well, it's a lot easier to put them together than it is to break them apart. And so we'll do a little bit of table manipulation to kind of review some stuff we learned in the Dino lab. So what we need to do is we need to add a new field, and we need to calculate some values in this table right here. But because this is an Excel spreadsheet, we can't actually manipulate the data in there. We need to be working with a table that's in the native ArcGIS format. So we'll right-click on this sheet 1 and go to Data, and we'll go Export. And what we're going to want to do is we're going to want to export this data into our Lab 4 folder, and we want to save it as a DBase file. So I'll call this Lab 4 export, and it's a .dbf, which is a DBase file. So we'll hit Save, and just confirm that our path is right, and we'll hit OK. And yes, we want to add that to the current map. And for nice file management, we'll go ahead and remove the old table from the table of contents. Just to make sure the export worked right, I'll open the table. Everything looks good, and so we need a new table that contains both of our new field, which with street num and street name. So I'll click on my table options and go to Add Field. We're going to call this Address. We're going to make it a text field, and because some addresses might be long, we'll make it 100 characters. And we'll hit OK, and now we have a nice empty address field. Now, to populate this with data, we'll right-click on the address field and go to Field Calculator. We'll hit Yes. And we're going to want to use street name and street num, and we're going to want to combine them using this AND operator here, so it links two fields together. But we need to be careful because we need a space in between, where if we just used AND and we did nothing, we would have 709, no space, West Main Street. And that's not how a real address should look. So what we'll do here is we'll click street num, and then we'll hit the AND button, and we'll hit space and double quotes, another space, and we'll end the double quotes. And so what this is doing is it's putting a space in between our two field names. And so then we'll hit AND again, and we'll pick up street name. So this is what your field calculator expression should look like. And then I'll go ahead and hit OK. And now you can see that we have a nice, address data populated in this field. So everything looks good. I'm going to go ahead and close this table and go back to run my geocoding operation, where I will right-click on my table, go to Geocode Addresses. I will pick my Radford Geocoder. I will hit OK. And now it will match my field. So my street or intersection or address is the address field, city, and state name. I go ahead and hit OK. And it's telling me that it's matched 100% of my records, so I don't have to manually match anything. I hit the close button, and I'm going to make these a little bit bigger so that we can see them. And look, I have 3 points, which are my 3 restaurants. I'll actually make those red so you can see them better. And if I wanted to know which restaurant was what, I could right click and turn on labels, or we could also use the eye tool, right? And so we can see here what this address locator has kind of done. It's used the information in our table to plot a point. It's retained that info, but it's also added some other information telling us about the type of geocoder, what the matched address was, which side of the street it was on, so on and so forth. Okay, so that's the first step. Now the second step is to plot the same point locations, but using the XY data that we recorded and not the address itself. So a little bit of a different process. Again, though, it all starts with a right click on the table, and we go down to display XY data. Excuse me. Now, again, it's kind of field matched for us. So it's like, hey, in the table there's an X field, there's also a Y field, so we'll use those to plot it. But look what it's doing. It's using the coordinate system of the base map. In this case, it's in meters. And meters is not what we recorded our data in. We actually used decimal degrees. So if we plotted the XY location of our restaurants using the wrong coordinate system, we can hit OK just to see what happens. We have no data where it should be. In reality, it plotted it somewhere, well, who even knows where? It's maybe in like South America or South Pole or something. It's actually at it's looking at our decimal degrees and it's thinking it's in meters. So that's not right. It's the wrong thing to do, but it's a very common mistake, which I just wanted to show you what that would look like. So we'll go back and we'll redo that operation where we display XY data, and we pick a coordinate system that's more appropriate. So in this case, we need one that's in decimal degrees. These would be geographic coordinate systems, and we'll pick one for the whole world, which is commonly used with GPS, which is the WGS 1984 coordinate system and datum. So I'll hit OK on that, and now we'll run this DisplayXY tool, and now you can see our points have shown up where they should in the real world. So again, I'll do some symbology things here, and maybe change this color to green, hit OK, and now we have 2 different realizations of where these restaurants exist. In red, it's been geocoded using an address, and in green, it's the XY coordinate that we've extracted from Google Earth. So now maybe the question is, which one is better? There might not be any real answer for that, but if we want to do some comparisons, we could maybe go out and get another base map. We'll get the world imagery map, so we can look at maybe where these places are, the buildings are in the real world. So we'll type in world imagery, and we'll use the add one, and we'll zoom over here into McAdoo's. And so we can see that even though when I was in Google Earth and I hovered my cursor over the center of the building, I'm going to type in GPS here. The point is actually displayed over here on the road, and it's very similar to my geocoded point. So which one's actually better here? Well, I might be leaning towards the GPS point because it's kind of right in front of the door. But again, no real answer for what is better or what is worse. But what's interesting is that with different types of imagery, different programs or software platforms, there can be differences in how things are mapped and represented, and what coordinates you extract from them. So you always have to remember that we're just dealing with representations of the real world, and everything isn't perfect. So you will have error and uncertainty in your data no matter what. Okay, so now we'll zoom over here to River City Grill, and we look at this. Now, let's see, I happen to know that the River City Grill is actually closer to right here. So this is a different building altogether where that particular GPS point was plotted. So something happened either with my cursor in Google Earth and where I plotted the map, or again, we could have some discrepancies between the data. So in this case, I think the geocoding data resulted in a better realization of where River City Grill is in the real world. Now, if we wanted a quantitative measurement of how far apart these are, you could use the measure tool, and you could, measure distances. So here we're getting, a discrepancy of about 33 meters. And if you wanted, you could put that in feet, and we see that, well, maybe the geocoding versus GPS operation has an error of about 110 feet. So it's just something that you need to be aware of. And so now, lastly, we'll go and we'll check out the SALs data. Okay, so here we have SALs, and we'll zoom in. And so here's an example of when the GPS points actually performed much better than the geocoding operation. And so we know that SALs is in this the shopping mall over here, and it's actually this area of the building. And so what the geocoder does is it interpolates where an address is along a road feature. And so if a building is really far away from a road, the geocoding operation is going to perform a little bit worse than actually figuring out where a GPS point is. So depending upon what area of the world that you're actually doing research in, maybe say you're urban or you're in a city, geocoding might work very well. But if you are in a rural place where houses are very far away from the road, the geocoder might not perform as well, and you might want to have GPS or some more detailed point level data. But again, no one is actually better, and it depends on what you need to be doing with your data. So now that we've seen that, we'll go back into D2L. Let's see, I'll just pull this over here and pull up our assignment. Okay, and we'll go to content. Sorry, wrong one. Master 250 and labs, lab 4. Okay, so we see here that we did the geocoding tool for restaurant locations. You do the DisplayXY tool. I want you to have a minimum of 10 restaurant locations, and then I want you to kind of compare the two data. Tell me which one you think is better, why, how did you measure them, were you unable to plot certain restaurants? If you were unable to, what was the cause of the errors? Do you think one method is more accurate than the other? So try to do about a half-page document explaining kind of your comparison and your analysis. And then I also want you to make one map that kind of shows the data points created from the two different methods. And what I want you to do is to put your answers in a Word document and then embed your map into that Word document, so export it as a JPEG or a PDF. And if you don't remember how to do that, you go in here. Remember, all maps have to have map elements, so give it a title, a north arrow, a legend, a scale bar, and so on, and then export that map as an image and embed it. And I highly suggest that you bump your resolution up to a minimum of 300 and the JPEG is a good file format to save as. So just complete that and submit it in the D2L Dropbox, and feel free to email me if you have any questions, or I'll be on Google Chat to help you guys. That's all. Bye.